in the next 10 minutes. We're going to journey from the Cold War's space race to today's trillion-dollar commercial frontier. We'll uncover how we went from state-funded spectacle to a bustling market driven by reusable rockets and venture capital. Stay with me to understand the economic engine behind modern space exploration, the key technologies slashing costs, and what the financial future beyond Earth really looks like. Space exploration was born not from commerce, but from competition. The Cold War defined its early financial model, a state-driven arms race cloaked in scientific ambition. In 1957, the Soviet Union's launch of Sputnik triggered the United States to invest billions in NASA, culminating in the 1969 Apollo moon landing achievement that cost approximately $25 billion United States dollars at the time, which is over $200 billion United States dollars in today's dollars. Early space exploration was entirely government-funded. Technology was a byproduct of geopolitical rivalry, not profit. Yet, it set the stage for one of the most consequential transfers of technology in history, from missile propulsion to microprocessors. By the late 20th century, financial fatigue forced a shift in how space was funded. Governments realized that sustaining billion-dollar missions for prestige alone was unsustainable. The 1980s and 1990s saw the rise of privatization and international collaboration. The International Space Station, costing over $150 billion United States dollars, was shared among 15 nations. This period introduced a financial model of cost sharing, where national space agencies pooled budgets to maintain a presence beyond Earth. At the same time, telecommunications satellites became the first commercially viable segment of the space economy, signaling that space could, in fact, pay dividends. The 21st century ushered in a radical change in the commercialization of space. Companies like SpaceX, Blue Origin, and Rocket Lab transformed exploration from a bureaucratic enterprise into a competitive market. Elon Musk's SpaceX, founded in 2002, broke cost barriers by developing reusable rockets, cutting launch costs from United States dollar 18,000 per kilogram on the space shuttle to under 2,000 United States dollars per kilogram with the Falcon 9. The financial logic was simple: reduce cost per launch, increase cadence, and enable sustainable economics. Venture capital followed. By 2024, private investment in space startups had exceeded $20 billion United States dollars annually, driven by the promise of satellites, logistics, and data monetization. The technological breakthroughs underpinning this new era center around propulsion efficiency, material science, and automation. Reusability, long considered impossible, became the backbone of modern aerospace finance. SpaceX's Falcon boosters can fly up to 15 times, saving 70 to 80% of manufacturing costs. Additive manufacturing, or 3D printing, slashed prototyping cycles from months to weeks. Artificial intelligence and autonomous navigation enabled precision landings that were once cinematic dreams. The result is a dramatic drop in marginal costs. turning spaceflight into a scalable business rather than a state-subsidized spectacle. Satellites are the most profitable segment of the space economy today. The global satellite industry generates over $280 billion annually, spanning broadband, imaging, and navigation. Low Earth orbit constellations like Starlink and OneWeb promise universal internet coverage, creating multi-billion-dollar revenue streams. The underlying technologies, more satellites, known as CubeSats, miniaturized sensors, and AI-driven analytics, has democratized space access. Financially, this segment represents a rare convergence, a high capital, high-yield industry that simultaneously drives digital inclusion. Every satellite launched now serves as both a communication node and a financial asset. As of 2025, space exploration sits at the intersection of geopolitics, technology, and venture finance. NASA, the European Space Agency, Roscosmos, and others continue to lead deep space missions, but private companies dominate near-Earth activity. The Artemis program, aimed at returning humans to the Moon, operates under a hybrid public-private structure. Meanwhile, China's space agency has accelerated its own lunar and Mars programs, investing over $12 billion annually. This dynamic balance of competition and collaboration has transformed space into a global economic ecosystem, not just a scientific frontier. The economics of space follow a distinct logic: high initial capital, exponential long-term potential. Funding sources include national budgets, private equity, venture capital, and increasingly sovereign wealth funds. Financial models blend traditional infrastructure financing with frontier investment logic, similar to early oil exploration or the birth of the Internet. Emerging financial instruments like space ETFs, debt securitization for satellite constellations, and orbital insurance markets have legitimized space as an investable asset class. The valuation of the global space economy surpassed $540 billion in 2024, with projections of $1.8 trillion by 2035. The next breakthroughs lie beyond Earth's gravitational well. Nuclear thermal propulsion could cut Mars travel time from 7 months to 3, while in-site resource utilization, extracting oxygen and fuel from lunar or Martian soil, may reduce payload costs dramatically. Quantum communication promises unhackable satellite networks. Meanwhile, AI-led robotics will soon construct off-world habitats autonomously. Each of these technologies carries transformative financial implications: reduced mission risk, lower capital burn, and new opportunities for interplanetary logistics markets. The most ambitious and controversial financial frontier is space mining. Asteroids rich in platinum, cobalt, and rare earth elements could theoretically yield trillions in value. Companies like Planetary Resources and Transastra have already filed patents and prototypes for extraction technologies. The challenge is the cost-to-return ratio. Current technology still makes asteroid mining prohibitively expensive. However, advancements in autonomous robotics, in-orbit refueling, and AI-based mapping could shift that calculus by the 2030s. The first profitable extraterrestrial industry may not be colonization, but commodities. Space is evolving from a domain of discovery to a domain of commerce. The next decade will define whether humanity can manage this expansion, sustainably balancing scientific curiosity with economic pragmatism. As finance and technology converge, space becomes a mirror of earthly ambition, driven by innovation, tempered by risk, and measured in returns. The most powerful insight is this: the new space race is not between nations, but between visions of the future. One seeks dominance, the other coexistence among the stars. The path humanity chooses will decide whether the space economy becomes a symbol of unity or yet another frontier of inequality. Thank you so much for joining me on this deep dive into the economics of space. If you found this analysis insightful, please give this video a thumbs up and subscribe to the channel for more content like this. We have more exciting topics coming up, so hit that notification bell and stay tuned. See you in the next one.